All right. There's been some questions about how to do this rise over the run thing. Okay, how to run up a flight of stairs, and this staircase that this is in my backyard, and this isn't quite high enough. I could have gone to but I think the kids are out there doing some kind of sports or something. I could have ran to the junior high just up the street from me, up the hill. There's two of them, two junior highs right next to each other. And some of the kids go to Liberty High School, and some of the kids go to Liberty North. It's really kind of strange how that worked. But anyway, taking the rise or the run of a staircase, and then we're going to run up the stairs. Now, what do we mean by the rise? Well, that's how tall the staircase is. And if I take and measure it in centimeters, then we'll convert it to meters. So here's my ruler, and it looks like whoops, let me do it this way. It's usually best to go one through whatever. Yeah, 17. My rise is 17 centimeters, and there are 10 steps here. So that's 17 times 10 is 170 centimeters, which is 1.7 meters high. I would really like for that to be a lot higher, okay? But that's okay for the demo on how to do it. So that's the rise. And then what you do is I'm going to take my mass. I'm going to lie about my mass is 100 kilograms, just to keep it easy. I'm probably closer to 120 kilograms. No, actually, I've lost about 25 pounds since the start of COVID because I've been running 30 miles a week. I ain't got nothing else to do in the morning. No, I don't have to commute, so it's nice. I get nice runs in, and the weather's been unbelievably beautiful. But anyway, so I'm going to jog up. So to get my gravitational potential energy is my mass, which I'm going to say is 100 kilograms to keep it simple, times the pull of gravity, which is 9.8 meters per second squared. So 100 times 9.8 is equal 100 times 9.8 should be around 980. That's why I had my calculator. 980 times the height, 17 centimeters, which is the rise of the step, 17 centimeters times 10. So that's 170, but converted to meters, so times 1.7. It's 1.7 meters high. So my total gravitational potential energy going up there, I'm going to raise my energy 1,666 joules, because that's what 100 times 9.8 times 1.7 equals. Now, the tricky part, and I don't even know why I threw this in here, but I asked you to come up with the added kinetic energy that you're adding to the system as you go from the bottom to the top. Now, what we're going to have to do is measure the diagonal that I'm going to be running. Okay. Now, I didn't realize I had a nice diagonal right here. I could have just put the ruler on or put a tape measure on and just measured that diagonal all the way up and then kind of ran it down to here. But the way we do it is good old Pythagorean theorem. Okay, rise of 17 centimeters, and the run is lengthwise, is a steppy step on. That's everything's the opposite. That's the steppy step on. Okay, that's your run. Right? And the run of this step is 28 centimeters. So I take 28 squared. I'm going to do the Pythagorean theorem. 28 squared plus 17 squared. Get those two numbers and then take the square root of that. So I'll take 28 squared. 28 squared plus 17 squared. That's equal to 1,073. I'm going to take the square root of that. And that comes out to be about 33. That comes out to be 33 centimeters, which is 0.33 meters. So I take 0.33. So I take 0.33 times 10, and I get 3.3 meters going up that way, which makes sense. because that's the way you want. That's kind of the ratio that you want. Now I'm not having you compute the angle. I'm curious as to what the angle is though, just because I'm a nerd. So I'll take the inverse tangent of 17 over 28. Yeah, the angle of these stairs is only 31 degrees. It's not steep. Now, my house, which you can't see, it's a classic old, or it's about 60 years old house, or 55 years. I'm 60 years old. It's about 55 years old house that was built in this new subdivision back in 1965 to 75. In fact, I grew up in a house right over there. And so what we have is, what am I even talking about? What am I saying? A staircase from the top of the stairs to the bottom to our basement. It's steep as hell. It's 7 inches. The rise over the run is 45 degrees, and it's 7 inches and 7 inches, which is ridiculous. I watched he's 7 now, so he survived it. But I watched and he's very athletic, so that's one reason. Even at 3 years old, Santiago, grandson, he rolled down the last 2/3 of the steps. He missed a step when we were going down, and it wasn't carpeted yet. It is now, but so in older homes you get much more steeper staircases. There's also very steep staircases. They're hidden, but in the older buildings on UMKC campus, there's some pretty steep staircases also, because they didn't worry about the rise over the run back then, but now with all the new regulations that have come out. So that's how you compute how far you're going to go. Now, what I'm going to do to compute my power. So here I'm going to compute my power. So let me get as my granddaughter Penelope used to call it, my 5 phone out here, and let's go to the timer, which I can never find anything on here that I want when I want it. Okay, it is on the timer. So I'm going to reset. So I want it on the stopwatch. There we go. So I want it on the stopwatch, and I already know that I'm going to go 1.7 meters high. Okay, so I already know that energy. Now I also know I'm going to go the 3.3 meters this way, and I'm going to time how long it takes me to do that. Okay, so here we go. Ha! Let me run. Mark, get set, go. Okay. If you walk it, now the sun's coming out again. All right, so if you walk this thing, it's that took me 5.3 seconds. All right, so now I've got my data. Let's go inside. So I got my data there, and my time was 5.32 seconds. I'll show you how to fill out this chart now when we go inside. I should have done this. I should have given you this at the very beginning. I got lazy. So let me turn that. Let me get everything out of my hand so I can turn this off, and we can record the second half here in a minute. Okay. So now you're looking at my screen here. Let me get it set up. So we got. Let's write down our data that we got. So I had the rise for one stair was 17 centimeters, as I recall, and I forgot already what the run for one stair was, but I can figure that out real quick. It was 28 centimeters. Okay, calculate the diagonal length of one stair. Well, the diagonal length would equal the square root of 17 squared plus 28 squared. And the way I did this on my calculator, I just went 17, hit the x squared, plus 28, hit the x squared key, hit equals, okay? And then you get a number, and then hit your square root button. So hit your equals, then hit your square root button, and that'll be it. And I believe that that came out to be 31, 0.33 meters. Okay, so that's the diagonal length of one stair. I had 10 stairs that I went up. I'm hoping you'll have 15 to 16 or something like that. If you're older like I am and you just want to walk it like I did, that's fine. That's fine. Total height of stairs in centimeters would be 170. Total height, so convert that to meters, 170 centimeters divided by 100 centimeters per meter gives me 1.7 meters. The diagonal distance, 330 centimeters, 3.3 meters. Okay? Calculate your mass. All right, fine. I could get on the scale. I could get on this. Boy, could I get on the scale. All right, I'm going to say I'm 100 kilograms. And I really think I am 100 kilograms. All right, and you know, I'm not checking names when I'm grading these things. If I ever grade them, no, I will. I promise. Put it on my mama. I'll grade these things. All right. So anyway, so now calculate your gravitational potential energy. The gravitational potential energy is the height of the stairs. So the gravitational potential energy is equal to mg times h. So my total height was 2.8. No, it was 1.7 meters. So I've got 100 times 9.8 times 1.7 meters is my gravitational potential energy. So I'd type in 100 times 9.8 times 1.7, and that's 1,666 joules. Okay, that number is never going to change. So when I go to my chart, this is always going to be 1,600. You know, for 5 trials. So if I did 5 trials, these would all be the same. Okay, these would all be the same. All right. So my time I took was 5.38 seconds. What did I say? 5.32 seconds. My time was 5.32 seconds. And by the way, one of your classmates said, "What do you mean you can't time yourself?" And I said, "Well, it's impossible to time yourself." Well, yeah, if you're sprinting, but I just proved she's right. Oh, I hate that. So Becky was right. Okay, you can do it if you're just going to take your leisure with these fancy phones. Because I got 5.32 seconds. There's absolutely no way on God's green earth if I had a stopwatch I could get it that accurate. That was amazing. All right, so okay, you win, I lose. So the average velocity is equal to the distance that I went, which was 3.3 meters. The diagonal distance divided by 5.32 seconds is equal to 3.3 divided by 5.32 is equal to 0.62 meters per second. Okay, now then, to compute my kinetic energy, the kinetic energy is equal to 1/2 my mass times that average velocity squared. I'm sorry, I'm a nerd. If I got an average, I got to put a bar over it. So that's my average velocity. So my kinetic energy, I'm going to compute it down here for you, is equal to, my kinetic energy is equal to 1/2 0.5, because that's 1/2, times 100 times 0.62 squared. Now this is going to be laughable compared to 19.2 joules. Okay, so do I need to add my, really? I mean, it's barely 2% of what the gravitational potential energy is. The Mother Earth is pulling on us really hard. That's a lot of work to do to overcome Mother Earth. All right. For my legs to push me up those stairs compared to Mother Earth holding me down here to keep me from flying to the moon, that just doesn't compare. But that's okay. I'll still add these two energies together. Now this one's not going to, this one will change as I get more tired, or if I say, to heck with that, I'm going to run it. All right. This one will change a little bit, all right, because your average velocity might change over each trial. Okay. And so now I'm going to add them together, and I get plus 1685.22 joules. Oh, so my power, I got to add those, divide by the time. And so power is equal to 1685 joules divided by the 5.32 seconds. Now this is just for one trial. Joules per second, that gives me my power. 316 watts. So I'm like, yeah. Mechanical energy wise, the amount of calories I burned off was a lot more than that, or more, probably 80%. Add an 80% to that, to the number of, because the joules of 1685, 1.6 kilojoules, it's not a lot. Because one calorie is 4,186 joules. Okay, the calories in our thing. So my energy I burned off going up those stairs wasn't much. It was a third of a calorie, but actually it was probably quite a bit more. You can maybe even multiply that by, or divide it by 0.8, or divided by 0.2. Yeah. I get a ballpark. Yeah, it's still not much, 0.37 calories. I mean, what it was, I mean, it's 5.32 seconds. I mean, that's not a lot. That's not a lot. Okay. So that's how you do this. So that's how you do this. Okay. And comparing me to Clydesdale, I'm half a Clydesdale. In running circles, since I'm over 200 pounds, I'm 6'2", over 200 pounds, and when I go for runs, we're called Clydesdales because a lot of the runners are smaller. Let's just put it that way. Okay, that's how you do this lab. All right, let's have it due a week from yesterday, Tuesday. So that'll work. That works for me.